Okay, now traditional session at the end of the lecture on how to do the things in R. So I'll show you how to make one sample and two sample t-test in R and how to calculate the power, a couple of examples that we used. So let's start with one sample t-test. You already know the function. We used it for calculating confidence intervals. So let's make a one sample t-test. And let's start with both tails, okay? So both tails, meaning that mu is either equal or not equal to. Let's use 146, okay? So let's start for VADE. So we have t-test, then we provide the sample. It will be, I already got the data, so I have to run this one. It will be data VADE. By default, it tests for mu equal to 0, okay? So if you want to change this, you have to specify the mu, and this in this case 146. And then you don't have to do anything else because by default it thinks that it should be both tails, and the significance level in this case we don't care about it because it will give us a p. So let's show the result. So that's the result. You can see that this is our t value, 2.1, approximately 2.1. This is the p-value, which gives you a chance to get a sample like you have, on even worse if in fact the average chloride content in the whole river is 146. You see 6.6, so we cannot reject this null hypothesis. Then if you calculate this for Riba, data Riba, then the same mu, 146. Then if we show the results, so you can see that the p-value is about the same. So we cannot reject null hypothesis that the chloride content in the whole river can be exactly 146. Now, and you can see that the t-value is minus 2.14. And if you compare these t-values, 2.1, approximately 2.1 and minus 2.14, with the ones that we calculated using the pen casting, you will find out that they are actually absolute. Now, and as we've seen before, we also got the confidence interval for the chloride, for the average chloride content in the river. Now let's talk about left tail. Left tail. And you remember the left tail is when we test that the thing. If you use the left tail, then the sample will become extreme if the t-value is negative, right? And what it means? It means that if the value is negative, it means that the population, the sample mean, is smaller than the population. So it means that we assume that the mu is actually equal or larger than 1. Now, how to do that? We do absolutely the same code, t-test. We provide the sample, the VADE. Then we provide the mu, 146. And then we should provide the alternative hypothesis. So what will be the alternative hypothesis? Well, if the null hypothesis is greater or equal, then the alternative hypothesis will be smaller or less, right? So in this case, we say the alternative hypothesis. Let's see what it shows us, okay? So we believe that VADA is at least 146, so it's quite contaminated in this case. And then you can see that the p-value is very large. So indeed, we cannot reject this null hypothesis. It seems like it's likely that to get a sample like we have, or even worse, if VADA is contaminated. So it has 146 or larger. But if we do it for Riba, I will just copy it. So we change the sample size. So in this case, you will see that the p-value is quite small. It's only 3% chance to get a sample like we have, or even more extreme, if Riba is indeed contaminated. It's 3%. Now we can make also it's for right tail. So the null hypothesis, it's either equal or below 146. So in this case, our null hypothesis is that the rivers are not contaminated. So I just copy and paste the previous code and change only the alternative hypothesis. In this case, the alternative hypothesis will be greater. So let's see what it says for VADE. So now, look, the p-value is 0.331. So it's 3.3% chance to get a sample like we have, or even worse, if VADE is the whole river is not contaminated. So it's pretty extreme here. And then if we do it for Riba, now you can see that it's 96.9%. even 97%. Okay, so if we assume that the riba is not contaminated, that's the chance that to get a sample like we have. So we cannot reject null hypothesis. Now let's compare the variables. Let's do the two samples. This test. And in this case, we simply provide both samples to the function t-test. So we don't have to specify any mu because we compare the average. So first it will be Wade. Well, if we don't specify alternative hypothesis, it will be by default two-tail hypothesis. So it will find out how likely the average chloride content in this rivers is equal. So let's see what the test says. So the test says is less than 1%, 0.8% chance. And again, if you compare it with our calculations, you will find the same value, 0.8% chance to get samples like we have, or even more extreme, if the whole rivers, if we take these two rivers, they have the same average chloride. So it's very small chance. So we cannot say we cannot accept null hypothesis in this case. Now let me show you the one tail test. So let's start with alternative hypothesis. Less. You remember, if alternative hypothesis is smaller, it means that the null hypothesis is the first is larger or equal than the second. So it means that the null hypothesis in this case, that Wade is has either equal average chloride content in Ribe or even larger. Okay, so that's the result, and you can see it's very likely, right? That's the chance to get a sample like we have, or even more extreme, if indeed Wade is more contaminated. Then we just use another tail, which is greater. In this case, our null hypothesis is that actually Wade is smaller or equal than Ribe. So average chloride content in Wade in the whole river is either smaller or equal to the average content of. Then of course we expect to get a very small value, which is 0.4%. 0.4%. Again, exactly the one we got in our calculation. Then just a couple of examples for the power calculation. For the power calculation, we need to know the effect, and we need to know the standard deviation, right? So let's use, for example, let's say standard deviation is 10, and we would like to know the power if sample size is 10, and for example, the size, the delta is 5. Okay, so will we be able to see a contaminated river if it's contaminated by 5 milligrams per liter larger than 146, than this limit? So we just take the power for t-test. You can see that R has functions to calculate power for different tests. We will use this one, it's for t. Okay. So what we need to provide? Well, first of all, we provide delta. Delta is our delta. Then n is our n. Standard deviation is deviation. What else we need to provide? We need to provide also the significance level. By default, it's 0.05, so it's not necessary, but I will do it anyway. Then there's two extra parameters, which is the alternative hypothesis. And in this case, it's we don't need to provide any alternative hypothesis in particular. We just need to say, is it two-tail or one-tail? Okay, so let's say one-sided. It's one tail test. And then the type of test, either it's one sample or two sample. And it's our case, it's one sample test, right? So it's for one sample. And then I need to show the. So that's the. See, n is not found. I need to run this first. Now let's see the results. So this is n, delta, and standard deviations that we provided, significance level. This is the power. Look, it's only 43% chance that we will see this effect if it's present. So if river is contaminated more than is contaminated by approximately by 5 milligrams per liter above the limit, then only 42% chance that this test will show us. Okay. Now, if we change n to 30, then the chance is now 85%. So it's doubled. Okay, so just a bit bigger sample size and the chance gets. Okay, so that's the power of it. You see, in this case, we don't use any sample because we don't need it. We can use the standard deviation only because that gives us an idea of standard deviation of the. Then the other parameters is that we are going to use for the experiment.